Hey guys, this is Siri, and I'm back with another video on PyTorch, and this video is going to be about transforms and transformations on your data. And the idea behind transforming your data and applying some transformations on it is the fact that you can't pass in your data into a machine learning model just as you found it when you just got your hands on the data, right? You need to do some cleaning up, some transformations so that your model is able to take it in and do its analysis on it. And PyTorch gives us two handy parameters for every Torch Vision data set. And these two parameters allow you to apply some transformations on the two different pieces of data that you would normally encounter, which are your features and your labels. Okay, and this is speaking in the context of an image data set. And so the two parameters we have are transform and target transform. And the transform parameter allows you to transform and change up, using some computation, of course, change up your features. And by the way, your features are just like the patterns that your model recognizes and encounters. And also it's just your data, your image, your raw images. And they change it up, that parameter changes it up into normalized tensors. And tensors, like we talked about in our first video, I think, is like the basic building block of PyTorch and of deep learning and machine learning. And so that's how we transform our features. And the way we transform our labels is interesting because originally we have some categorical titles, right, for our different classes. And the way we would normally change it up is by assigning integers to each of those categories. So, for example, if you had fashion MNIST, which is what we're going to be dealing with today, and if you had like ankle boots and I'm trying to remember, I think it was like dresses and trousers and whatnot. And if you assign them each like 0, 1, 2, 3, 4, and so on, it seems like a good idea, but it's actually not, because then your model's gonna think, oh, there's some sort of like ascending like relationship between the two, or between all of the categories, and this sort of means something, and I should base my analysis on it, or some part of my analysis on it. And that's not the impression or idea that we want to give to our model. And so what we do with our our labels, is we transform them into a one-hot encoded tensor. And we'll talk more about this in another video. I'll just give you like a brief idea, and I promise I will talk about it in another video because it's an important and integral part of this transformation process, this transforming. But in a nutshell, one hot encoding is just like you have a few dummy variables that are going to come into play, and it's a sort of binary way of representing these integers that don't give that same impression to your model like the ascending numbers. Okay, and to make these transformations, there are two things that we need to utilize here. One is the toTensor function, and the other is lambda. Okay, and we'll talk about these in more detail in a few minutes once we do our necessary imports and Yeah. Okay, so we're going to be dealing with the fashion MNIST data set once again. Okay, by the way, let's create a title just so that we know what we're dealing with here. Okay, so we're going to have from Torch Vision, and there are other things like this, like Torch Audio and other for other streams of data. So this is for vision, computer vision. So we have import Torch Vision, from Torch Vision, import datasets. Okay, and we made a whole video on datasets and data loaders, so I definitely recommend checking that out. Okay, and then from Torch Vision .transforms, we're going to import the two things we talked about, 2tensor and lambda. And you notice how these are capitalized. It's like part of Torch Vision. It's not like the regular lambda that we use in Python. Although we are going to be using it, this is not the one I'm referring to here. So it would be good to brush up on your lambda stuff from just basic Python. But I will be talking about it, so it's okay if you're not. If that's not at the top of your mind right now. So, okay, so we have some data, and we're going to be setting it equal to datasets.fashion MNIST. Okay, and like I mentioned, we have some parameters that we take is root, we have train, we have download, we have transform, and we have target transform. And if you remember, in our previous video, we set these equal to none. And today we're not going to be doing that because we actually want to transform the data, and that's the purpose of the video, just to get familiar with transforming our data. Okay, so it's going to be our target transform. Okay, and so the root, I'm going to just set equal to data once again. And this is going to be my training data, so I'm going to set it equal to true. If it was my test data, I would set it equal to false. Okay, download is equal to true. Transform is equal to, this is the transformation of our features, and this is the transformation of our labels. Okay, so transform is equal to the 2tensor, like we talked about. 2tensor. Okay, let's put this on another line. 2tensor, and the target transform is equal to lambda and our normal Python lambda. And the way these work is that you have a lambda, okay, and lambdas are just functions. They are functions. You call them lambda functions, but they're anonymous functions. You know how in regular Python, when we have to define a function, we use the def keyword and then the name of the function, and then our code goes right after the colon. Well, here in Python we just have lambda, and then we have the input, which you can set it whatever you want it. You can set it to whatever you want. That's what I meant. And so what I'm gonna do is set lambda y. You can make it x. You can make it whatever you want. And I'm going to set it equal to torch.zeros 10, float, or dtype, sorry, because that's the name of the parameter, and we're setting it to the default value of torch.float. Okay, and we're going to do something. This is still part of the, whoa. This is still part of the parameters. So, okay, transform is equal to 2tensor, target transform is equal to lambda y, to torch.zeros, 10 comma d type equals torch dot float, and we're going to call a function on it. We're going to call dot scatter. And it's going to be 0 comma. That's so weird whenever I torch dot tensor and y, and we're going to set the value equal to 1. Okay, so this is a lot, I know, but to tensor, so what this does is it converts each of the PIL images, which are the type of images in the fashion MNIST data set. It converts that to the normalized tensors. And when I say normalized, I mean the values are going to be in between 0 and 1. And the reason why it's important to have your tensors be normalized after each computation is because if you don't normalize them and if you don't convert them to values that are in between 0 and 1, and the way you convert it is just by or I don't know how you do it, but like you keep the relationship between each of the numbers in the tensor. And so when you do that, you stop the values from blowing up, and you stop the gradient from blowing up or vanishing. So that's why it's important to normalize your tensors. And gradients are just like derivatives of each computation. And if you don't know what that means, that's okay. We'll go into more detail in an autograd video. Yeah, but I think that's it for now. So transform equals to tensor, and it converts that PIL image, like I said, or it can also convert a NumPy ND array into a float tensor. And like I said before, it brings all the pixels and the tensors to a range from 0 to 1. And now lambda transformations. Okay, so we turn this integer into a 1-hot encoded tensor for the reason I mentioned before, because like the 0, 1, 2, 3, 4 categorical or integer encoded values are not enough. You need to go a step further. Not only do you need to make the ankle boot, the dress, and the shoe, or I don't know. Not only do you need to convert those to numbers and integers, but you need to go a step further and actually convert those integers to 1-hot encoded tensors, which just pull in and plug in like dummy variables so that the model can understand it better and not jump to conclusions. And so what we're doing here is that if you watched my my tensors video, or if you already know about them, you see here actually, the only thing I did here is load the data set. So what I'm supposed to do here is actually, never mind. Okay, so we do all these transformations in these arguments and parameters. And so here we're creating a tensor of size 10. Okay, it's all zeros. That's what it populates the tensor with. We also have torch.rand. We have torch.ones. You pick, okay? And the D type is going to be torch.float. And we apply the scatter. And all of this just, like I said, transforms these integer labels, which is why we're setting it, which is why this is the value of our target transform, right? Our target is just our labels and the actual outcome. Okay, so that's what we're doing here. Those are the two things that we transform. Okay, and yeah, I hope you learned something from this video. Okay, let's just run this to see if this runs. Okay, it's downloading it again. Okay, it downloaded and everything ran smoothly. Okay, so that was the point of this video, just to talk about transforms. We can do transformations on features and labels, and this is what we transform them to, and we put all that information into the parameter. Okay, thank you so much, and have a great day.